that we have. And today we're going to get into spending the day and tomorrow on solving these systems, dealing with graphing. So when we talk about solving, we've got our step process like we usually do. So the first thing that we're going to do is to put those equations into y equals mx plus b form. Now, as you can see in this case, they are already there, so that makes our job a little bit easier. So our second step is going to be to graph it. So I'm going to start off, I'm going to call this one my red line, and I see that it's got a y-intercept of 5, so I'm going to go up 5 and put a dot on the y-axis. And then I see that I have my slope of 3, which means I'm going to go up 3, forward 1. Now, one of the things I do want you to get in the habit of doing, because in looking at your homework, I've been seeing a lot of you who have been making very short lines, which you can't tell exactly with parallel and perpendicular, or especially perpendicular if they intersect, if you don't make them intersect. So I want you to get in the habit of using the entire graph and going consistently up 3 over 1 or down 3 back 1. So we can make sure we cover the whole graph, because if they don't intersect, you're not going to be able to solve it. And the nice part is that if your graph is slightly off, like you can see mine are, you can see where it should be when you graph the other one. Now then I have my blue line, which I see crosses the y-axis at -3 and has a slope of -1. Remember, because if there's no number, it's negative. So that means I have a slope of -1 over 1, just like this one was 3 over 1. And I can go down 1, forward 1, but I can see that going this way, I'm not going to hit. So I'm going to go back this way. And I make that one big because that is their point of intersection. And I'm still going to keep going, and then I'm going to connect my dots. And I see that my point of intersection is right here. We write our point of intersection as when we determine it, as an ordered pair. So as you can remember, this is y-axis, this is x-axis, so we're going to write our point of intersection as -2, -1, which is actually our solution to the equation. Our final step, however, though, is going to be the last piece, which is going to be to check the solution in the original equations. Because if maybe you graphed it wrong, maybe you solved it wrong, and we want to make sure that this is set correctly. So we're going to go back, and that means that we're going to take our x and our y, and we're going to put them into each of our equations. So starting with our red equation, y we said was -1, and we have 3 times our x of -2 plus 5. Well, 3 times -2 is -6 plus 5, and that does equal -1. So it does check out for the red equation. Now when we go look at the blue equation, we've got -1 equals negative of -2. I apologize. -3. Now, a negative, remember, is a positive. You can also think of it as that negative in front of the x right here. It means opposite. The opposite of -2 is +2. So we got 2 minus 3, and that does equal -1, so it does check out. The final step, if you recall from our set of directions, is to identify the system type. Because we have here one solution, this means that it's going to be consistent and independent, because there is only one solution. So I will be looking for both this part as well as this solution when you're doing your homework. So let's take a look at the next example here. Here we have y equals -2x plus 1 and y equals -2/3 x plus 5. Since they're in slope-intercept form, we're going to go ahead and graph them. And so I'm going to graph my red equation, which is at +1 crossing the y-axis. It's -2 over 1, so that means I'm going to go down 2, forward 1, and I'm going to go covering the whole entire graph. And going up 2, back 1, all the way through and make sure that we cover our entire graph. And then our next one, our blue line, is going to be crossing at 5. 1, 2, 3, 4, 5. And we have a slope of negative 2/3. So I'm going to go down 2, forward 3, down 2, forward 3. And I see going this way I'm not going to hit it, so I'm going to go up 2, back 3. And there's our point of intersection, up 2, back 3. And then connect my dots. And I see here my ordered pair that I have where this crosses is negative 1, 2, 3. And then we go up 1, 2, 3, 4, 5, 6, 7. So hopefully I counted right. So let's go ahead and check this. So we have 7 equals negative 2 times negative 3 plus 1. Negative 2 times negative 3 is 6, plus 1, 7 does equal 7. So it checks out in the red equation. In the blue equation, we've got 7 equals negative 2/3 times negative 3 plus 5. Well, when we put this over 1, these will cancel. Negative times negative is positive, leaving us with 2 plus 5, which does equal 7. So it does work out. And because we have one solution, that means that we have it consistent and independent.